Hello and welcome. Today, you're joining us for the webinar, Cloud Crises, Real Stories from the Field. We've got a few people that are coming in, so I might just give a little bit of time before we start, but very excited for this session and glad to have you all here today. I should really have organized some music at this point, but I'm sure you'll have to do without it. We won't give it too long, just a little while for everyone to filter in as we're starting on the hour. This is one of my favorite topics, this one, as we're going to be covering real-world breaches and some real-world tooling that's used in cloud attacks, which is something I always like talking about. You'll have to forgive me if there's too large a smile on my face. I'm just quite interested by this topic. And with that, we've given a little time for everyone to join, so let's kick off properly. Hello and welcome again to Cloud Crises, Real Stories from the Field, a webinar where we're going to be talking about attacks on cloud environments, tooling that attacks cloud environments, and we're going to hear some real-world bug bounty stories. We've got two people on the call today, myself, Chris Hosking. I'm the AI and cloud security evangelist for SentinelOne, and I'm also joined by my colleague, Anand. Anand, do you want to introduce yourself, please?
Hi, hello everyone. Thank you so much for joining us today. So even indeed, this is also one of my favorite topic around the real world findings in cloud APIs and stuff. So a bit about myself, I was one of the top ranked hackers for companies like Uber, Twitter, Salesforce, LinkedIn. And at SentinelOne, I work on the cloud security product.
All right, thank you. Well, let's get going. There's a lot for us to cover today. First, I just wanted to quickly cover why are we having any of these conversations. Adversary focus has really shifted to the cloud because of growing cloud and container adoption. Just 3 stats to start with. Gartner believes that by 2025, 95% of all new workloads straight to the cloud. That's 19 out of 20. Wasabi put out an excellent report recently that believes that 93% of organizations are increasing their cloud object storage this year. And Gartner, in a longer-term horizon, believes that by 2028, 95% of organizations will be building and running containerized applications. So for adversaries that are looking to access IP, it's likely to be in cloud object storage. That are looking to disrupt business-critical applications, they may be containerized. Attack surfaces are just getting, by and large, slightly more cloudy. Now, unfortunately, that means that there is an increase in the number of breaches that we're seeing in cloud and container environments. And there's a few different numbers on this. I've chosen to put a number that isn't one of the more sensational ones out there, but unfortunately, everyone does agree these numbers are on the rise. I think part of the reason why these numbers are on the rise is because there's now a lowered barrier to entry for cloud attacks that we haven't previously seen. And a lot of these attacks are more and more automated. And that's actually going to lead us to some of our first look into real world stories where we're going to cover some open source tooling that is readily available. Now, my colleagues over at Sentinel Labs have done excellent reporting on the 3 that I'm going to briefly chat on today. So if you want to know about any of these in more detail, highly recommend that you go over there and read about those. But I'm going to be talking about FBot, Alien Fox, and Predator AI. All of these are essentially collections of different tools that are available to automate attacking cloud environments and often triggering actions for things like cloud email services as well. Now, what Alien Fox does, to give you one example, first you've got to use an aggregation service like Security IX or Leak Trails. So you've got to find your targets first, right? And what we're targeting here is insecure web frameworks, so like Joomla, WordPress, Drupal. And what Alien Fox is going to do is it's going to dump the config files of the misconfigured services. It's going to pass through, so it's going to automate discovery, extract the keys that it's looking for. It's going to import Boto3 locally, use the access key that it's found from AWS, create a brand new login profile, delete the original. The new login profile is going to have a hard-coded password, and then it's going to bump up admin access privileges. This is the kind of tooling that's available automated and open source. This isn't secretive Russian Chinese stuff. This is open source stuff. Now, Predator AI isn't open source. This is for sale, but it's readily found. something that I find really interesting about Predator AI is it's similar to these other tool sets where it's like a Swiss Army knife of a different set of tooling to target cloud environments. But in this case, what Predator AI has done is they've put a generative AI chat interface on top of it, so you can engage with the tool set through that chatbot function. Now, this is readily available. We can see here it's been successful in defacing this website. I've blurred a little bit because they've made a political statement that wasn't too kind, so we've gotten rid of that. But here's an example of Predator AI in the real world, right? The next thing that I wanted to talk about is the fact that attack sophistication is literally increasing when we look at attacks on cloud and container environments. MITRE ATT&CK, which isn't POCs and made up attacks. This is real world attacks in order for it to become a technique. They've grown from 50 to 61 in the last 2 years for cloud IaaS techniques and 28 to 39 for container attacks. So we're literally seeing an expansion of what's possible within discovery, lateral movement, persistence, credential access, and all of those different MITRE tactics and techniques. But what's really causing cloud incidents? This always makes me think of that scene in Harry Potter of the, why is it always you three? Why is it always you three? Vulnerabilities, compromised credentials, misconfigured assets. And I think at this point, this is first where I'd like to throw to my colleague Anand. Anand, do these three ring true to you in your experience? Are these three the correct three to talk about? And could you chat to us a little bit about your history with vulnerabilities and the types of vulnerabilities you've seen out in the wild that get hit up?
Yeah, so if we look at the graph, of course, there has been like so much rise in the number of vulnerabilities. But if we look at the early years, let's say 2015, 2016, the number of proof of exploits which were out there on public repos or which were publicly available was very less. But what we have started seeing now is like these exploits are immediately made available over these public repos, and attackers, hackers, they can use them immediately to exploit companies' infrastructure, right? So what I'm trying to say is like there has been, of course, a rise in number of vulnerabilities, but the rise, what matters is like rise of proof of concept of these exploits, and also the known exploited vulnerabilities have significantly increased in past number of years, and we'll see these increasing more and more. So that's the problem.
I think something that's interesting as well is that it's not always brand new vulnerabilities that get new POC exploits, right? Sometimes it's older vulnerabilities that are still being hit.
Yeah, that's another problem. Like as a bounty hunter, I have seen exploiting vulnerabilities which are still relevant, mostly in older frameworks like ASP.NET, PHP, Django, all of it. So that's another problem. And because the main problem is companies often lack this visibility, like what all can be exploited from an attacker, from an outside perspective, right? So that's what is lacking right now. Companies often end up seeing a report with like 1,000 vulnerabilities where there is no exploitability factor in it. That's the problem. So it's hidden somewhere inside.
I think something that's also interesting to talk about when we talk about vulnerabilities is speed to exploit. There was an example earlier on in this year where our colleagues over at Rapid7 shared a proof of concept. Within 22 minutes, that concept was used to attack vulnerabilities in the wild for Team City, which is a software that provides some CI/CD tooling. But that's the time frame, 22 minutes, and that was observed by our colleagues at Cloudflare, who obviously see a large part of internet traffic. I would love to hear a real world story, and I know you've got a few. Could you walk us through this specific disclosure of yours, Anand, for a vulnerability in a major software vendor that you found?
Yeah, so this vulnerability existed in a major software vendor, and it existed in an open source software called Jenkins. And just to share some more background, this major software vendor is really major, and they might have like so many cloud security tools which are deployed inside, right? And they have a very large security team which is also deployed, so many tools around vulnerability management, cloud security, SDLC tools, all of it. but still, like, I was able to figure this out from outside. And the reason for that is like the missing piece around visibility of exploit, what all can be exploited from an attacker from outside. So what I did was I went through the company's domain, figured out all the subdomains which the company is having from outside it, as an outsider. Then basically I fingerprinted what all technologies are running on these domains, and then I got to know that there are few Jenkins servers. And then I went more deeper using some script, of course, again some script. What's the version that's out there, and then the exploit was out there in public. I used the exploit to basically test it out, and it was working, right? So I immediately notified the team, and they ended up fixing it. Yeah.
I believe in this case, this CVE actually allowed you to trigger a build of a repo of your own choice, right? So you could build sort of, commit architecture that wasn't even theirs, and controlled by an adversary, which is quite a powerful vulnerability, this one.
Yeah.
Next up, I wanted to share a story that I found particularly interesting of what attacks beginning on vulnerabilities can look like. I wanted to talk about crypto mining, in particular an adversary that's known as Scarlet Eel. And shout out to my colleagues over at Sysdig for some of their phenomenal insight and research into this particular adversary. The reason why I like talking about it is it's often a great way to challenge what people think of as a crypto mining attack. In this case, it was a vulnerable public-facing web app hosted in a Kubernetes cluster on AWS, and the vulnerability allowed for remote code execution. Now, what that meant was the adversary was able to, bash to get the XMRig executable running, going, the miner config file, have the crypto mining start. Right there, you've got access, you've got remote code execution, you've got command and control, you've got your impact. They're now, building up your CPU usage, and they're, essentially they're stealing resource. That's where a lot of people think these attacks stop. In reality, what they also did was quite sophisticated discovery and credential access. Via Bash, they were able to enumerate temporary security credentials of the EC2 host sitting underneath that Kubernetes cluster. With those credentials, they were able to, use AWS API call and query Lambda and actually exfil code associated with Lambda, as well as access 1 terabyte of files in S3. They were able to successfully disable logging on CloudTrail, which means it's then incredibly difficult to find what this adversary did after that point, without some, some deep expertise and logging aside from CloudTrail. And they were also able to access Terraform state files within S3 and attempted lateral movement with some of the credentials that they found from there. And so I quite like bringing this up because it's not just crypto mining that starts and ends with, hey, they've bumped up your CPU resource a little. It becomes quite a sophisticated campaign that begins with a simple vulnerability. But let's move on to credentials, as that was the second topic that we wanted to talk about today. Credential leakage and credential theft, it's what starts a lot of attacks. A lot of this can be ominous in that it's credential theft, and a lot of this can be happen by mistake, where people are unknowingly leaking their credentials that are then found and used against them. I'll say that code repositories are being actively targeted for people looking for these mistakes, so that they can credential harvest and take the opportunity to build out an attack campaign from there. What I'll also say is that in terms of credential theft, we're seeing some really interesting campaigns open up. Account takeover. Often, if a popular library is compromised, the first thing that it's done is small changes are made to say that if you're using latest of this library, why don't you send me your AWS account details? Send me your keys, send me your creds. Such was the case of a CTX, the CTX takeover, which was a PyPy library, downloaded more than 200,000 times, 3,000 times a day at the time that the attack happened. Was a Turkish university student who said that he was just trying to use some of the skills he was learning in his computer science course. It was found about 2 weeks later. But for anyone, because this kid had been able to spoof the account and make changes to this popular library where the original maintainer had disappeared a few years before, they were able to change it and ask for people's creds and keys. And I'll also say that another really interesting development in credential theft campaigns is I'm now seeing developers are targeted specifically for the credentials that they have. Not always necessarily the human credentials, but often the machine credentials that they might have access to as well. And I've got a great little story on this coming up. But before I get to it, I'd love to hear another Anand story. Anand, I'm sure you've got more than a few stories about reporting on credential leakage that you found. Could you walk us through this one, please?
Yeah, so this is, of course, like one of my favorite finding that I've been discovering from past many years. So on a high level, the problem with secret detection is most of the time companies end up focusing on like private repo secret detection, but they don't really have any visibility on like what all their developers are leaking on public repository. So I had written some script to look at all the secrets which are being leaked on these VCS providers, right? And on a day, I figured out that one of the developer of a large major software vendor, he ended up leaking the AWS keys on the public repo, and those keys were valid, like very valid, right? And they had full access. You could dump everything using those keys or do more stuff inside, right? So this was discovered within like 10 minutes of time by using a script. And I reported it to the bounty program. They ended up fixing it immediately, and 10K bounty was paid for like 10 minutes. So, but this is a real major problem that should be fixed ASAP.
A good return on investment, right? 10K for 10 minutes. And yeah. Could you go into a little bit about the base 64, the fact that this wasn't picked up by some of the native tooling?
Yeah, so originally most of these VCS providers, they have their own automation, which basically detects the leaked credentials on a public repo of, let's say if it's AWS, GCP, all of it, right? But this specific credential was in base 64. And so it was undetected by the VCS provider. And we were able to detect it because we had some other things. Basically, you decode the base 64 and then try to match the regex pattern with that of an AWS key, right? Yeah.
Nice. The real world story that I wanted to tell that centers around credential theft that targets developers this is a true story from late last year. This is a crypto organization, and the adversary here is Lazarus Group. For those of you that don't know Lazarus Group, this is North Korean state-sponsored cybercrime. And historically, they have targeted financial institutions and crypto organizations. Now, for a while, they've been running something that they call Operation Dream Job, where they've been putting out when they've been putting out job descriptions and fake job adverts. And when you ask for more details, the PDF or the doc of the JD included malicious macros. That's what this campaign used to be. We're now seeing an evolution of that. In this case, Lazarus Group identified, so they did reconnaissance and they targeted more than 10 developers of a development team of this particular crypto organization, and then they reached out to them with a lure. They impersonated Binance's head of talent, and they tried to set up fake technical interviews with these developers where they promised them an increase in wage should they come join the organization, which of course was not in fact Binance. If they went through the interview process, they were tasked with building out like a hello world, basically, but were asked to say, hey, can you use some of our assets? And so can you use some stuff from our repo so that we can see that you can work with our code? Unfortunately, one of the developers was using his work laptop, and within that weaponized NPM repository was an artifact that included browser credential dumping. Now, this enabled the threat actor to get access to Password Manager, which included credentials for GitHub and credentials to Docker Hub. So we're seeing the credential theft is sort of rapidly expanding here, but they're targeting the developers. What did they do from there? Well, now this specific developer had no access to production, but did work on a legacy application within Docker Hub. So the threat actor was able to map the business logic of that application and examine container images, and in fact pulled an image that was tagged as production, implanted scripts within that image, and then put that back. And so this is internal image implant that they're able to achieve here. And so part of what they did was, they put a ping here of let's ping out to a domain so that when a successful ping is returned, we can tell that that application is live and running. They built a series of surgical bash. So what they did was they waited for it to be running live, and then they began their campaign of reverse shells from an environment that they, of course, ran. They were able to get access to a hot wallet because they knew exactly what they had to do to get access to the environment that they wanted to. They were tested with one single transaction. Ethereum at the time was about $3,000. The next was 41.3 US drained million. And so this is a particularly interesting one for a number of reasons. Part of why this is interesting is a developer is targeted for the credentials that they have and for the access that they have into an environment. The fact that the law happens across LinkedIn, quite interesting as well. What's also interesting is this organization had quite sophisticated DevSecOps processes in place, as in they had quite a lot of fantastic tooling. Now, running latest or running, tagged with production from your own repo, that's potentially not the best, but they had security tooling in place. What they didn't have was runtime security for this specific part of the environment, because this legacy application was, only run sparsely, and the environment was built to be ephemeral. And so there was a belief that, if this is short lasting and doesn't run very often, the scope of the impact can't be that large. Unfortunately, it was. Now we've got a couple other real world stories, just to sort of showcase how prevalent this is. There was 7 different Microsoft employees that on GitHub were exposing their credentials. This was disclosed. 4 of them were found to be active at the time of this specific publishing. I want to draw your attention to the date here, April 9. That's going to become important in just a little bit. But also recently, we had the pleasure of hosting Anand here in Australia. If you can't tell, I'm Aussie. And at the same time, there was a breach that was happening in Australia. Anand, do you want to talk us through the Football Australia breach?
Yeah, so again, my favorite topic, secret leakage. So what really happened in this case is Football Australia was having a public web application, a public URL where it was hosting some of the website stuff. So what really happened is on the source code of the public application, there was an AWS key which was hard-coded in an HTML file, right? So the attackers, right, they constantly look out for these kind of things. They scrap your public domains, then they go inside your what all files are publicly accessible, and then they do regex pattern matching to figure out if something is a credential or not, right? So this was like figured out in this case by a malicious attacker, and then they ended up dumping the player details and everything, and the entire issue is out there in public right now. But this could have been easily fixed if proper public secret leakage detection was in place, proper SDLC guidelines or proper SDLC was in place for detecting hard-coded secrets even during the code commit itself, right? So basic mistake, but this ended up becoming dangerous in this case.
And it's probably worthwhile talking about that so much of this can be addressed with a secure development lifecycle, but also often credential leakage can happen because of cloud misconfigurations as well. And I think that might be a nice sort of segue to cloud misconfigs to talk about that. This is a conversation that's so often talked about. There's that popular statistic from Gartner of 99% of cloud breaches are going to be due to human failure, aka likely misconfiguring your own environment or developing your own environment with known vulnerabilities. While cloud security posture management tools have been around for quite a while now, this remains an incredibly challenging field for a lot of organizations. I think that's because of how many new cloud services there are. It's not just the same 10 that we have to look at. Or more and more, there's new cloud services, including perhaps Bedrock and generative AI services that all of the cloud providers have launched. It's also worthwhile noting that how these are leveraged externally by threat actors has developed as well. It used to just be one scary misconfiguration. Storage is public and not encoded. That was all it was. Now we're seeing threat actors combine smaller misconfigurations into attack chains. A lot of threat actors are targeting misconfigurations or causing misconfigurations involving cloud identity because it expands their access. It achieves privilege escalation. In fact, we've recently put out a blog within our cloud and container attack and defense series where we look at a GCP example of privilege escalation due to a vulnerability, where the one vulnerability then allows an attacker to expand their access rights in GCP environments. But I think it's a really interesting challenge for us all is that we now need to sort of differentiate between what misconfigurations have been caused because of our own doing, my own developers, versus what misconfigurations represent a compromise artifact because someone externally has been able to change something after they've got access to secrets or after they've pinged a vulnerability. Now, I said pay attention to April 9th before. We've got April 10 now. No, this isn't the same breach. This is a separate breach. I don't want to rag on Microsoft so much, but I wanted to sort of draw this picture of if an organization with security standards and as large as Microsoft can make these mistakes, if the inventor of Azure can misconfigure it themselves, it's clearly a challenge for everyone. In this case, this misconfiguration led to some source code being leaked for the Bing search engine, which is perhaps why there was so lax standards around it, because no one particularly wants to steal Bing, but there you go. But Anand, I know you've got another story for us. Can you talk us through this misconfiguration bounty story of yours?
Yeah, so again, this is like my another favorite topic around subdomain takeovers. So this vulnerability existed in one of the large social media site where they had a stale Route 53 entry. So what this means is they had a Route 53 entry which was pointed to an S3 bucket. And by design, if let's say that S3 bucket is deleted from the main account, right? Any user, any attacker could claim it. Like if I delete it from my account, Chris can claim it right away. And then the record would still exist in my account, and I would be pointing to Chris's maybe S3 bucket. So whatever is uploaded by you at that point in time, it will be visible in my domain, basically defacement, or I could do session hijacking, all of that using that. So this existed in one of a large social media company. There was a stale S3 bucket and a Route 53 entry. I was able to do a basic DNS lookup and get hold of the S3 bucket name and basically take over the S3 bucket. And then I could deface it, all of it, right? So this was immediately fixed by the social media company, but still in 2024, you would find this is a very prevalent issue, and you won't find any of any of the cloud security vendors covering this. But this is a widespread issue which is exploited by attackers every other time for session hijacking and defacing the company.
Which is quite a large impact. All of these issues contribute to, I think, the fact that there's quite an imbalance in cloud security. There's always, as Anand has said previously, really clear goals for attackers, right? They've just got to find one way in, where defenders are unfortunately thinly spread across a large amount of alerts, often inclusive of false positives, and they have to deal with not only complex applications and complex infrastructure, but a complex security stack when it comes to cloud security. This is part of why I like to make the sort of the big bold claim that cloud security is broken. That's not because cloud security tools are broken, but it's that we need so much more to keep cloud environments safe and secure now that a lot of what's historically worked is really fraying at the seams now. I see a lot of organizations have a lot of different tools. Gartner believes that there's a consolidation happening in market. I don't know if it's quite happening to these timeframes. I can certainly say that most organizations I talk to will have more than 6 or 7 different tools across their pipeline, across the configuration of their environment, across runtime security. I don't think it's necessarily a problem that there's different screens. It's that they're not connected to each other. They're disparate and disconnected. They lack context and correlation. And so, if there's something, if I need to get an understanding of what's happening in my container environment, I need to know, well, what's the health of my running container? What's the configuration of the services that I'm using to run the container, like the container registry and the container service from the cloud provider? What's the health of the container image, application and OS level? What's the safety of the host that's running that environment? How well configured is my Kubernetes cluster itself? There's quite a few different views, and I need to tie together all of that, as well as see what's happening with machine identities in relation to this environment. And a lot of these tools they're noisy, they don't have any priorities. They're mostly about preventing things from happening rather than understanding what is happening, and they quite often lack machine speed security. And anything that you'd throw in here, is this ringing a bell for you as you looked at a lot of the tools that were available?
Yeah, this was one of the reasons I started PingSafe, now part of SentinelOne. This was the main problem that I saw in the market, that every other company was using like 6 tools to fix cloud security, and these tools were not passing any context to each other. And I still see that as a problem, and the exploitability piece was like completely missing, right? And attackers were exploiting these things by using open source scripts within like 5 minutes. Without having these tools deployed internally at that point in time. So I could well relate to it, and indeed this is still a problem in cloud security.
We actually asked our own developers a couple of years ago, specifically for our own environment, what was frustrating for them as they looked at cloud security. Because of course we're a software vendor. We've got a massive cloud environment. For them specifically, it was investigating and responding that was taking up their most time. And what that meant was, because the time suck was so great across hunting, investigating, and responding, was that they never got to proactive risk management. And they were kind of always on the back burn of responding to a large amount of alerts that they needed to validate, essentially, and a response time that was taking them too long. Now, I think these aren't just challenges that we see; they're challenges broadly in the market. I just want to briefly touch on 3 different stats because of some reporting that we've done recently and that our colleagues at Cloud Security Alliance have done. 85% of organizations are saying that they have struggled validating and prioritizing events. 71% of organizations believe that their cloud detection and response tooling is insufficient, and 77% feel unprepared to deal with cloud threats. I wanted to, similar to that last slide, give you our own view of this, because I can't always speak on behalf of everyone else. I've got to speak on behalf of SentinelOne. We've certainly felt the pain of cloud security as well. We don't have unlimited resources within our SOC team, and so I wanted to talk about why we made the decision to acquire PingSafe at Annens.org. Now, of course, PingSafe is now relaunched. That's been launched globally across it's available across multiple of our environments that are live. It's running within our environment. We've refactored the code base to make it more performant. Annen's team has done a number of new releases as well, including cloud infrastructure entitlement management, which is incredibly exciting. So I just wanted to sort of, you'll hear us move language from PingSafe to cloud native security, as that's launched. But if you want to read about our own SOC's use case, we've got a blog. So I recommend checking it out, but we'll go into a little bit of detail. But let's chat about cloud native security. Anand, could you walk us through the capabilities?
Yeah, so overall, on a very high level, CNS basically covers, it can identify misconfigurations in your cloud services across AWS, GCP, Azure, Alibaba, Oracle. It could figure out, detect misconfigurations and vulnerabilities in your VMs without any need for installing agents. It basically also helps you to enable some of the shift left stuff. For example, it could integrate with your GitHub, GitLab, Bitbucket, or your CI/CD pipelines to detect misconfigured Terraform templates, CloudFormation templates, and detect hard-coded secrets in your pipeline, and also detect misconfigurations in identity and Kubernetes environments as well.
And what I will say here is that these kind of bullet points is what I expect you to see from most cloud security vendors. Anand and I aren't going to hide that fact. This is what you'd expect to see from a lot of CNAP providers. But I wanted to talk about what we found to be special and why this has made such a difference to our security by going through a couple quotes and having Anand walk through a couple capabilities in more detail. Previously, we had 2 CNAP providers ourselves deployed for agentless security. Of course, we've always used our own agent-based security for runtime security, but we did have Wiz and Orca deployed. Wiz has some phenomenal capabilities around identifying combinations of misconfigurations, they're toxic combos. Orca's always had an incredibly strong history in agentless security, especially within the pipeline. This wasn't the extent of our tools as well. We were also leveraging TruffleHog. Still love what those guys do, and they're open source, so God bless them. As well as Sneak, who we still continue to use and we have an incredibly strong partnership with. If you leverage Sneak and SentinelOne, please make sure you're leveraging the integration there because I think it's incredibly strong. But we wanted to evaluate PingSafe because PingSafe was actually part of our program of investment. Is that right, Anand? Do you want to talk a little bit more about details there?
Yeah.
About the ventures, right?
Yeah, so basically we were based out by S Ventures for an investment before becoming part of SentinelOne, and that's where the security team came in and they wanted to understand what's differentiator from Wiz and Orca. And at that point in time, they started evaluating us, deployed us, and we were able to surface a couple of issues in the environment which were not even detected by Wiz and Orca from past many months. So that's where it got interesting.
Yeah, I bet. First quote here, standout feature, unique, was its capacity to monitor custom data within the environment and map custom environments as well. Would you be able to walk us through the security graph, Anand?
Yeah, so we have this feature called Graph Explorer, using which you could investigate vulnerable and exploitable instances in your environment. So what you could do using Graph Explorer is, so let's say you connect maybe 50 different or 100 different cloud accounts. We have the graph database on the backend, and using this Graph Explorer, it's very easy to use UI. You could search, let's say, list all the vulnerable instances impacted by some XCV and having an exploit which can be exploited from outside, right? So this, and you could maybe also write queries like specific to this particular cloud account, specific to this tag ID in the environment, in the entire environment itself. So of course, I could always write raw queries, but on Graph Explorer, it becomes really easier when you see all the options in a drop-down, which are the most used ones, right? And you write that query within seconds, and then you could create custom queries that will run again and again every other time if you want them to, right? Yeah.
And I might add on there, because I know that our security team appreciated this as well. It's not always very easy to come up with in your head all of the policies that you want to create. Like, like obviously I'm going to get policies from my vendor. I'm going to create, this niche policy and this niche policy. But sometimes you can't quite conceive of everything that you need to do. this ability to sort of visualize different specific parts of your cloud environment, say, actually, no, for this part, I want this specific alerting at this time. That ability to sort of navigate the environment and build policies while you're navigating that, that was quite useful for them. So I thought I'd flag that. But the next quote we've got here is that something they found exciting was the ability to examine cloud infrastructure from an attacker's perspective, which I think goes back to everything that you wanted to do from your bug bounty history, bringing into cloud native security. Can you tell us a little bit about what that attacker's perspective means to you and the offensive security engine?
Yeah, so if we look at some of the examples which I found in some of the larger companies, are right. I've been finding those examples since I've been seeing those examples from 2013, right? And they still exist. So what I wanted to do is I wanted to automate that entire process of fingerprinting your infrastructure from an inside perspective, and then exploiting those issues like an attacker from outside. And these are like harmless payload which any bug bounty hunter or any hacker would do from outside. So we called it offensive security engine, and it basically maps your entire infra outside. Like if there's, let's say, there is an instance which is running internally, then we see if that is exposed to public using an endpoint, and is there an open port of it on it. If there is any open port on it, we fingerprint the service. Like in this case, if that's a metabase instance, we figure out the version, and then we also send an exploit like an attacker, which is like an harmless payload to that metabase instance to confirm that this vulnerability exists. So if you look at this, this is the curl command which we actually sent to an AWS instance from outside, which was running metabase. And we were able to exploit it, and we were able to get hold of AWS and its secret key from outside. And this is what we call verified exploit paths, which is like very unique, and which basically helps a security person to only find and fix issues which are like really exploitable. I was one of the early security engineers at a very large e-commerce company in India, and I was always I was using the so-called tools at that point in time, and seeing like 2,000-page report coming to me, and most of the issues were like not exploitable at all. So it was like, as Chris said earlier, it was like super frustrating for me. So I thought I should fix this problem for all.
And I think that's so important as well, because attack paths, which we see a lot of in this cloud security industry, they're only theoretical unless you can prove them. And there's no point looking through 200 of them or starting with the wrong one if we can take on this extra work to say, no, this is what's really possible. Another thing that I love is that screenshot. I love to call this the so what artifact, because you can take that and send it to your developer team and say like, hey, forget the CVE number and the severity. This is what's possible from a non-blacklisted IP today. Is this serious enough for us to fix it? Yes? Okay, let's go. Here's everywhere it exists. Here's how we can remediate. We've got a couple other findings. Do you want to chat about these quickly, Anand?
Yes, these are another common findings in technologies like Grafana, PHP, customers exposing things with default credentials. PHP MyAdmin is still open to public in 2024. Swagger UI is again one of the most common thing that I see companies opening it, and they sometimes don't fix it. But as attackers, we use the APIs, the internal APIs, external APIs to find more information about this, right?
And we do see some really interesting things when we look at this.
Yeah.
Next up, we've got our own organization security team looking at the secret scanning capabilities, capable of identifying quite a large number of distinct secrets and credentials. Could you talk us through the secret scanning engine, please?
Yeah, so again, like we spoke about a couple of case studies which I found on large software companies, and this is still a problem as of today, right? So secret leakage, again, is a very big problem, and companies often lack leakage of detection of leakage of public secrets. So in CNS, we support more than 750 type of secrets, including cloud secrets, SaaS secrets, right? And it basically can crawl your developer repos if they are creating new repositories, copying code from internal repos and pushing outside, right? It could automatically figure out if something is getting leaked on public repos, as well as from your organization repositories as well. So you don't need to worry about any public secret leakages anymore. And what we additionally do on top of it is we have this something called verified credential leakage. So we are able to verify credentials by calling the third party API and show you this tag of valid, right? So even if you delete the repo, the most common mistake I see is like companies end up removing the repos, but they would still, the secret would still be valid, right? So that also is solved using CNS.
Yeah. And that's good just to stay on top of good behavior, because we might have a couple developers that find their mistake and cover their trails, but don't necessarily cover the security risk, right? Look, because of all these things, as Adam said earlier, another great quote from our examination, our evaluation, was that we were actually able to find risks and vulnerabilities that our existing solutions had missed. Subdomain takeover risk was present, as well as a couple others that we won't talk about. But what they found really game-changing was that there was verified findings with evidence. So that validation time frame that used to take them so long before, they could really quickly minimize. And what they found was that it empowered security teams to act decisively and minimized dependence on human vetting of alerts. And for us, that just kind of sounded like ourselves. That's what SentinelOne has always tried to do, leverage AI and ML with a number of different engines. With what we're doing with autonomous SOC with Purple AI, is we're trying to accelerate and empower security teams and minimize that time frame. So it felt like a natural fit for us, which is why we were able to remove our previously used solutions and implement PingSafe, now cloud native security. That's been a game changer for our security team. We've got a quote here from our deputy CISO. It'll take me a little bit too long to read it all, but sufficient to say that something that he was quite impressed by was they could now, in a concrete fashion, see how their work was being impactful. Here's something that was real and had evidence that something could happen here, and they were able to remove it and remediate it. I think I wouldn't spend too long on this, but certainly I see that there's a need for a holistic view across cloud security. That's something that SentinelOne is very involved in, is how can we help you, shift your security left, be well architected, and have runtime security. How can you have artifact scanning? How can you do cloud configuration and compliance and cloud workload protection? When it comes to our proposal for how you can solve these challenges, for us, it's about how can we get evidence-based about our proactive health, and how can we be autonomous about our reactive health, which is cloud native security and cloud workload security. For those of you that haven't seen an overview of our products in this space, it's not just cloud native security. It is, again, cloud workload security and cloud data security. Together, these form our comprehensive CNAP. Again, if you haven't seen cloud workload security, that's our agent-based AI and ML engines sitting on top of an eBPF sensor that's stable, scalable, protects some of the world's largest cloud environments, autonomously detects and blocks threats, and does exactly everything you need it to keep a running production environment safe and happy and clean. But with that, I might stop there because we've covered so much material today. Unfortunately, my colleague Anand does have to run, but I'll be present for some questions, should there be any from the field. But before we get into questions, I just want to say thank you again for your time today. Hope you've enjoyed our session, and a reminder to check out that series that we've just put up live of privilege escalation specific to Kubernetes environments, because we've got 2 great blogs there. Part 1 is theory, part 2 is a real-world example of that GCP use case. But thank you very much for your time.
Thank you.